Hello everyone, this is Vijaya Vandita. I am studying in Sri Venkateshwara College of Engineering. Today I am here to discuss about operating system. I'll be discussing about Amdahl's law. I am from the Department Computer Science and Engineering in Data Science. I think it will be helpful for you. First, let's move on to the introduction of Amdahl's law. To know more about Amdahl's law, let's see the introduction. Amdahl's law is a formula used to calculate the potential performance improvement of a system when only a portion of it is enhanced. It was proposed by computer architect Jean Amdahl in 1967. So Amdahl's law was proposed by an architect named Jean Amdahl in the year 1967. So Amdahl's law came into effect in the year 1967. Amdahl's law is a fundamental concept in parallel computing and helps in understanding the limitation of performance improvement. So using Amdahl's law, we can understand the limitation of performance improvements. Amdahl's law is named after the computer scientist Jean Amdahl. Jean Amdahl, as we know, is the founder of Amdahl's law, and it was presented at the AFIPS Spring Joint Computer Conference, which was held out in the year 1967. It is also known as Amdahl's argument. Now let's see the statement of Amdahl's law. What does Amdahl's law state? Amdahl's law states that when a part of system is improved, the overall system improvements will be proportional to how much that part makes up the system. Components that make up a larger portion of the system should be the focus of improvements. Also, that improvement of a system is limited by parts that cannot be improved. This is the statement of Amdahl's law. Next, let's see the formula for Amdahl's law. The formula is S equal to 1 divided by 1 minus P plus P by N. So we don't know the values of what is the variables S, P and N signify. So let's see what is the each denote. S denotes the speed of the system. So in order to calculate the speed of the system, we use the variable X. Next, P is the proportion of the system that can be improved. N denotes the number of processors in the system. So using N, the number of processors in the system can be calculated. Now let's see the advantages of Amdahl's law. It provides the way to quantify the maximum potential speed up that can be achieved by parallelizing a program, which can help guide decisions about hardware and software designs. It helps to identify the proportions of a program that are not easily parallelizable, which can guide efforts to optimize those proportions of the code. These are the advantages of Amdahl's law. Moving further, let's see an example of Amdahl's law. If a system has a single bottleneck that occupies 20% of the total execution time, and we add 4 more processors to the system, what would the speed be? So now we need to calculate the speed, that is S. The given values are N equal to 1 that occupies the processor 20% of the total, that is 20 divided by 100, we'll get 0.2. And here N equal to 4, that is we'll add 4 more processors. So N value is increased with 4. Previously it was 1, now we'll add 4, we'll get 5. So substitute the values of P and N in this equation and we'll get the speed of the system. After substitution and calculation, we'll get the final answer as 1.9. Let's see another example. Suppose we are considering an enhancement that runs 10 times faster than the original machine, but is usually only 40% of the time. What is the overall gain by incorporating the enhancement? So first, we have given the value of N as 10. Second, we have seen T equal to 40% of the time, that is 40% divided by 100, we'll get 0.4. So whenever the values are given in percent, we need to convert into decimal or integer values. After substituting in the same formula which is mentioned above, value of P we need to substitute as 0.4, value of N we need to substitute as 10. After calculation and simplification, we get the final answer as 1.56. Let's see the conclusion of Amdahl's law. Amdahl's law provides a value insight into the potential speed up of a system by considering the parallelizable and non-parallelizable portion of a task. It helps in making informed decisions about optimizing and improving the performance of this computer system. This is the conclusion of Amdahl's law. Hope you have understood the topics. Thanks for watching. Please do share, subscribe, and like my videos.